Good morning or good afternoon, everyone. Thanks for joining us. My name is Aya, and I'll be the moderator for today's webinar, C Segment Secure, IoT Device Visibility and Security with Ordr and Gigamon. Before I introduce our speakers, just a few housekeeping items. This session will be recorded and shared after the webinar. To learn more about Ordr and Gigamon's partnership, you can download our joint solution brief in the handout section of the GoToWebinar console. If you have any questions during the presentation, please feel free to ask in the question portion of the console, and we will get to them at the end of the webinar. I'd like to introduce our speakers. First, we have Craig, who's a principal engineer at Ordr and is driving next generation solutions that allow organizations keep pace with the hyper-connected Internet of Things through automated classification and microsegmentation using machine learning and AI on big data platforms. Prior to joining Ordr in 2018, Craig was a 20-year veteran with Cisco Systems, defining Cisco's policy and access control solutions, including Identity Services Engine and software-defined access. And our guest speaker today is Gordon Beath. Gordon oversees product marketing for Gigamon's product lines and the service provider vertical. He has over 30 years of experience in telecommunication product management, marketing, hardware, software development, and related next generation service areas. His background includes product, project, marketing, and account management positions for NetScout Systems, VSS Monitoring, Cisco, and Ericsson. Without further ado, I'll pass it over to our presenters. Craig, take it away.
Thank you, Aya. Welcome, everyone. So let's get to it. And this is the topic for today. And it is the fact that most customers are seeing an explosion of the userless, headless devices, things that don't run agents, things that connect to your network, and you may not even be aware that they're there. And there's just a huge volume of these different types of devices. And when you start realizing what comprises this type of device, it's, certainly all organizations will see things like smart office, your traditional printers and copiers, but now they're all connected through an IP interface, often communicating even out to the internet in some cases. You have the multimedia, so whether it's digital signage or other means of entertainment for your employees or patients or customers, and physical security. So the things that protect you, the badge access readers, the things that are watching over with the IP cameras and door locks. If you're in manufacturing, you have a number of different IP connected operational technology. And in healthcare, there's certainly a number of devices specific to the healthcare environment. And then facilities, which every organization, from things such as smart vending, thermostats, elevator controls, and then retail. And there's probably a whole other list of things like personal communication devices which have exploded onto the network, which are of concern. So getting a handle on these devices that are connecting requires that visibility. You can't protect what you can't see. And so some of the challenges in managing the IoT environment certainly is, what do I actually have? Can I track that? Can I correlate that to what I think I have in my asset database, or maybe it's just a spreadsheet? What are they doing on my network? Are they behaving normally? Do I have cameras acting like cameras? Are they doing something nefarious? I don't know that without actually having some type of network visibility. Are they vulnerable? So of these things that are connected, often they are running deprecated or very small kernels, if you will, of these older operating system, whether it be Windows-based or Linux or some other proprietary operating system. And these are things that are often not being patched and put you to greater exposure because of their inherent weaknesses. And then the question then becomes, how do I protect them? You've told me that there's no way to put an agent on these. They're connected. They're running some old software where there is no patches available. So how do I actually protect these devices from being impacted and the services they render, as well as being compromised and then being used to launch an attack? And then finally, are they used efficiently? So especially in like healthcare, where you have very expensive equipment often being leased, do I know that my MRI is actually being used properly? If I'm leasing hundreds of patient monitors, I would like to know if they're being used in a way that's most efficient. So with that, it all starts with data collection and getting visibility into things. And so a perfect start to this conversation will be to have Gordon Beat tell you more about Gigamon.
Yeah, thanks very much, Craig. Yes, so whether you've got a traditional IT type of network infrastructure or whether you have your OT type of infrastructure, the need to be able to get access to all the points in the network to see the traffic that you do need to see and collect all that traffic is kind of very crucial and paramount. And so therefore, the challenge is, how do I get to see all of those points with monitoring applications and ensure that, one, I get to see each piece of the traffic I need to look at to be able to secure the network completely and not miss something. And also, how do I ensure that I see the complete conversation in each monitoring application to be sure that it sees the application to see the entire conversation and be able to properly detect something. And it doesn't matter whether it's doing it for performance monitoring or security, which is the hot topic today. So the challenge is, okay, so one way to do it is you can actually try to deploy a device in every single location you need to get to, but that becomes unmanageable and probably not cost efficient, effective, I should say, and even manageable from a cost perspective. So therefore, there needs to be some kind of solution to allow you to do that, to see all the traffic and not have to deploy everywhere. And the other challenge with deploying everywhere is, like with things like asymmetrical routing, you're never sure that you're going to see the complete conversation coming down certain links or paths. So therefore, you need to be able to see a bigger picture to be able to bring it back and collect it all as one collective conversation or sets of conversations. So what Gigamon does is they have there it is, beautiful. Gigamon offers a visibility and analytics fabric, which allows you to get access to traffic from multiple points of different types, from different environments. It doesn't matter whether it's physical or virtual. Get access to that traffic and then bring it back and aggregate it together and then sort it out and feed it out to the various monitoring applications that need to see it. You know, it doesn't matter whether it's application performance monitoring, network performance monitoring, whether you're doing intrusion protection. You might even be forwarding it to trying to feed your firewalls in the same manner, and just looking for threats, detecting threats, responding to them. This fabric allows you to get the traffic from wherever and get a copy of that traffic, or even the actual traffic, to those devices as required. So to start off with, as we talked about, you need to be able to acquire the traffic. You need to be able to get access to it. Then once you've got it, you can aggregate it. You can actually filter it. You can even spread the load across multiple instances of the same device. And in a lot of cases, you may even want to transform the traffic. And the purpose of this is really, okay, so I've got a device such as an application performance monitoring tool that I've got there specifically to monitor certain types of applications. Well, there's going to be a lot of other traffic on the network that that tool doesn't really care about. So therefore, why overload the forwarding of the traffic to that device as well as that device itself with irrelevant traffic? So being able to remove send only the types of traffic and the applications you want. Then being able to detect at that level. Then there's other devices that may actually only want to see certain depth into the packet, because there's a lot of headers on traffic. Even beyond layer 4, you'll have HTTP headers and other headers inside HTTP. Maybe you just need to go to that depth, and so therefore being able to remove and slice off the irrelevant payload can actually make your tool farm a lot more effective, a lot more efficient. And some security devices only need to go a certain depth into the packets as well. And then some level of analysis could also be done within this fabric to feed other devices such as SIM tools and so on, where instead of sending the raw packets, we can just send net flow representations of, or IPFX representations of what's on the network, possibly even very rich metadata representations of the traffic in IPFix or maybe Ceph format to give the real elements that the monitoring application is interested in, not just the entire raw packet. And so therefore you can send a lot more data back and be a lot more efficient and effective in your monitoring environment as you need to, as fits the need. So if we look at some of the types of capabilities I was just referring to before, if you're going to reduce the traffic that's on the network, because you're collecting traffic from multiple points, now it doesn't matter whether you're using physical taps, which are the best way to actually get access to all 100% of the traffic on a specific link, or if you're relying on mirror or span ports on network switches. It doesn't matter which ones of those you're using. If you're collecting traffic from multiple points, there's a good chance you're going to get a lot of duplicates of the packets. You'll get some unique ones just from monitoring those multiple points, but you probably get a lot of duplicates as well. And so therefore, being able to remove those duplicates before you forward it on, it achieves two things. One, it's less traffic to send back to the devices, so it doesn't overload your links you're forwarding back the traffic to the devices on. It doesn't overload the tools themselves with irrelevant traffic. And it also avoids things like false positives. And for any device that's able to do its own deduplication, it also improves the performance of it. And you can get a significant saving by just doing deduplication, probably at least 50%. And then I talked about being able to remove elements of the packet. So you can either slice or truncate packets themselves on a packet by packet basis, or you can actually do it on a flow by flow basis. So once you've detected a flow, you could say, all right, I just want to see the initial setup, leading packets within a flow. And the other packets after that, either I don't want them at all, I could just remove the payload from those packets because I'm really not that interested in them. But I at least need to know that the flows existed and how they were set up and sort of running from the beginning. So this you can reduce volumes from anywhere between 60 to 90% by doing this type of traffic reduction. Now we move on to the next, and plus there's many more ways you can reduce traffic that's available. Then we can move on to the next section, which is really about transforming the traffic. So you're converting the traffic into a format that the devices need to be able to inspect them properly. I've talked about before being able to generate net flow or metadata. So that's one form of being able to convert the traffic. So extract the elements that are crucial from the raw packets and only forward that data onto the monitoring applications. This is one way to convert the traffic. The next one is about trying to expose traffic that's hidden by encryption. And we know, most of us know that around about 80% of the traffic that you find on the web today is actually encrypted. And in certain enterprises today, you might find a lot more than that's encrypted. Maybe almost all of their traffic is encrypted, particularly their application layer traffic. So therefore, the ability to be able to decrypt that and send it onto your monitoring applications is crucial. And the best place to do that is centrally. So within the visibility and analytics fabric provided by Gigamon, you can actually do that decryption inline, because when you get perfect forward secrecy used for encryption, and TLS 1.3 mandates that you can only use perfect forward secrecy, you can't rely on static keys anymore. Because of that, you need to be in line and be able to decrypt the traffic as it comes in and re-encrypt it as it goes out again, and then it allows you to forward on decrypted forms of the traffic to the devices that you need for the monitoring. And it doesn't matter if they're an inline firewall or IPS type device, or whether they're an out-of-band monitoring application. And even if you go back to the NetFlow and metadata situation, if you want to generate application layer rich metadata, the only way to produce that is once you've already decrypted the encrypted traffic. So both of these, in a sense, go hand in hand from that perspective. And plus, there's other ways to transform traffic as well. Now, in addition to the visibility and analytics fabric that Gigamon offers, Gigamon also offers a product called Threat Insight. And with Threat Insight, what it enables you to do is to detect and respond to any threats that may come along. You know, being able to detect positive, do true positive detections, being able to store up to 30 days of rich metadata, and then also make the most informed response decision is really critical, and that's really the power that the Gigamon Threat Insight provides. So it allows you to detect, to hunt for the sources and the causes of what you've detected, investigate further into it, and then be able to respond to help mitigate the problem. And so what this does is, combined with the Gigamon Visibility and Analytics Fabric, the Threat Insight is able to help provide very comprehensive visibility across your whole network, and be able to detect and provide very good analysis to then be able to respond appropriately. And that solution's offered as a managed service, security as a service type of solution. And the benefit from that is it's able to draw on a very large amount of knowledge that's been collected and is continually being collected and researched, all back into an advanced or an applied threat research database. And so by having this as a service, you can actually draw on that source and get the best benefit out of it. And it's an extremely powerful solution to be able to do your detection, hunting, and responding to those threats. You know, it's just finally, I'd like to wrap up and say that the Visibility and Analytics Fabric from Gigamon, and also combined with the Gigamon Threat Insight, allows us to provide a decent service to enterprises and operators of networks, allowing them to run fast, because in this day of digital transformation, being able to run fast is critical, and then being able to stay secure. So while you're moving quickly in an agile manner within your environments and with your network infrastructures, staying secure is actually extremely critical, and it's become even more so during the times that we've been going through recently, very challenging times, and it will continue to be very important as we get into the new tomorrow that's coming our way quickly. And then finally, being able to optimize the investments that are made by the enterprise and the operations organizations, you know, to allow you to make the best use of any monitoring and tool investments you've already made, and any investments you will make them as effective and efficient as possible, to allow your budgets that are going probably in a constrained situation these days, to go as far as they possibly can. All right, and with that, I will hand back to Craig.
Thanks, Gordon. So with that, you can see that using the Gigamon Visibility Analytics Fabric, you are now able to get visibility across your entire environment in a very optimized way. And that bodes very well for the Ordr Systems Control Engine, because we are a data sponge. And we like receiving as much data about the network traffic, as well as the application information that's embedded with them, so that we can inventory all the devices on the network. So with that communication and getting that data from the Visibility Analytics Fabric, we're able to provide passive, agentless detection, discovery, and classification with high-res detail of each device. In the demonstration, you'll see what kind of detail I'm referring to, beyond just saying that this is a specific model of security camera. This is the firmware, this is the operating system, the model, here's where it's located on the network. And that's all done passively, again, without any agents. This is for all IoT, OT, unmanaged as well as managed devices. The next piece is to analyze the environment. So watching the devices, the communications, and again, this is where it's that valuable feed that we're receiving from Gigamon to say, show us the communications across the entire network. Show me what they're doing so I can then, we will translate that into, this is the behavior for a device, a group of like devices, or for, say, all of your facility devices. This is what they're doing on the network. This is what's normal. This is what's abnormal. And then for things like healthcare is tracking device utilization. Because we have been able to detect and tell you what things like the detailed operating system and models, that can then be correlated automatically to existing threat and vulnerability feeds like the ICS CERT or FDA recall data in the case of healthcare, and track vulnerabilities that are inherent within these devices. The next piece that Ordr provides is the detection of threats. So we do this in two primary ways. One is we do have a built-in intrusion detection service and receive feeds from major providers to be able to say, within the traffic, even if it's communications over the right ports and protocols, is there any attacks born within that traffic that I may not be able to see? And we'll provide that details. And then certainly to say, is that infusion pump, is that point of sale system, whatever that device might be, is it behaving like that device should be doing? Especially in the case of IoT, they tend to have very prescriptive behavior patterns. So we can quickly spot when things are acting in a way that's deviant, specific to your environment. We will assess the risk, so we coalesce all the information from what we've learned, as well as bringing in resource and threat vulnerability data from other sources, such as your vulnerability assessment scanner, to create a composite risk score, and then be able to accelerate incident response, because all of the data that we receive in this rich classification and security information is something we will share with your existing tools, whether that be with your SOC tools and say logging and Splunk tools. Your asset management systems could be things like ServiceNow, generating service tickets, or Volo, whatever that might be. We are wanting to make them much more intelligent about these things, which often just show up as IPs on the network. And then finally, let's do something about it. It's not enough just to say, yep, there's a problem, and then generate a ticket. How do I provide actionable intelligence to actually create protection, particularly for these things that cannot protect themselves? I can't just throw the latest Norton 360 onto a onto an IoT device. I can't just say, oh, give me the latest patch for that. It's running some ancient operating system. No, you eventually have to come to the realization that the way to protect them is to create some type of segmentation and protect them. And we'll do that in an automated fashion. So let's get more into details of how we work. So the first thing, and this is why that being able to receive information from Gigamon, and where we will take raw packets, we'll actually just decode the traffic, look at the applications, such as your building automation, could be industrial protocols, healthcare protocols, and all the protocols that are used by different things that are normally connecting to your network across the board, and be able to ferret out rich information. And we'll also correlate that to your existing asset management systems, the systems that are tracking unique information, like who owns this device? When's this due for maintenance? Who would I contact if there's an issue? What's the asset tag, which I might want to use as a tracking mechanism within service ticketing? And being able to correlate that information and map that so that every device and group of like devices in your environment, we have a behavioral map, a conversation that says this is what this device should be doing in the network. And that's what you see in the bottom right-hand corner is the flow genome. It's a graphical representation of the communications to one device or group of devices to all other things to say, let's show you what it is. And by the way, let's color code those so I can tell you what's the risk related to each one of these conversations. Because when I generate a segmentation policy, I only want to allow the good stuff. If I want to see what is abnormal, I want to be able to quickly see and ferret that out. Now that information about the classification and devices goes back into our central intelligence pool of learning and feeds back into our learning model. Now, I just spoke about device intelligence. How do we then map that to network intelligence, which is let's consume information from the network directly or through maybe network management tools, through identity stores like Active Directory, so I can correlate devices to users, to points in the network, down to things like which VLAN, which interface, which access point or SSID did this thing connect to. Meld that with the behavioral model so I can generate true segmentation and micro-segmentation policies that are understood by your existing infrastructure or your existing security devices or policy servers. So you see a couple examples where for this a particular device, we'll say this particular building automation control device should only be doing these things. And by the way, here's the policy. I can hand it to you on a platter and say, this is the configuration to make this secure at your firewall, through something like network access control or directly on the switches or wireless systems, or I can push a button and automate that process. So we take out all of the manual effort and error that are typically involved in generating segmentation policy that does not disrupt your existing services. So how is this deployed? And this will give you a better insight of how we integrate with Gigamon. So we have at the very bottom left, you're seeing a model where we have a number of sensors. These are the things that will take and collect raw data from the network and provide and process that, and then trickle metadata, the information that matters, to our analytics engine. Now, this is also the point that you would connect to if you're managing the system. You want to see your devices and see the security information and the flows and do any type of configuration. This platform can exist on premises. We have some customers that are sensitive to where data sits, and they choose to have that on premises. But we also support a model that could live as a cloud service. So we manage the updates and the upkeep, and you would still have the sensor because that's collecting the raw data or high volume data, and that is being fed. And then we have our cloud service, which is providing continuous updates and threat intelligence and security feeds and other information to keep the system up to date. Now, it often comes to question, do I need, where would I place these sensors? Well, normally we place them in a central location, and you'll see that what will happen is when devices, often the IoT devices, they're not smart unto themselves. They need to talk to something that's smarter. They usually have some type of controller, a server that sits in a more central location. And that's where we will see that data. And in that instant, be able to provide the detailed classification, rich attribution, such as the make, model, hardware, software information. Will provide very rich security information, as well as detect anomalies in that traffic, and be able to provide and generate policies that are relevant for this, call this north-south, right? It's something from the edge of your network coming through, and it could be going to your data center, could be going to another part, but this is where the hub of communications. This is typically, and we will receive that off of a span or tap, or there are some cases where there's traffic that might be traversing locally and going left to right, east-west, lower in the network, or maybe at a remote site. In those cases, we can consume things like NetFlow. So it may not be, you may not want to push and provision a sensor to be at that remote site or further down in the in your network. So you can leverage NetFlow as a way to be able to see that east-west traffic for anomaly detection, or if it's to generate policy. Now, if you're generating policy to protect things as they enter or leave your network, then maybe it's sufficient to see the traffic at this point. But if you are trying to say, you know what, I want to protect and actually lock things down at the port of entry, then this could be important information to see. Now, the reason why I bring this up is let's look at the same scenario with Gigamon involved. So Gigamon will have visibility into all points of your network. So now I can see full rich information, full packet, which has already been optimized, distilled, deduplicated, or even decrypted for the SSL traffic, and have that automatically fed to us from the visibility and analytics fabric. But what about communications that might be happening between specific systems localized in the data center or in the access layer, or maybe at a remote branch? While I could position sensors or leverage NetFlow, I can take advantage of the visibility analytics fabric to have all of that data sent to me, optimized on a silver platter, so I have complete visibility. Again, we're a data sponge, so the more you send to us, the better is the information we'll be able to provide. And this is for those who are more IT-centric, just kind of giving you that view of the level of connectivity and visibility across your entire enterprise network, whether it be within a large campus, in the data center, at your branch offices, or even cloud. Because when you have that requirement to monitor traffic, whether it's for application analysis, security analytics, troubleshooting, or in the case of being able to get this rich IoT visibility with Ordr, this totally simplifies that deployment, where rather connecting from a span or tap, you just have one connection that is Gigamon, and then everything else can be served from that one platform very simply. I do want to call out, there are other sources of data that Ordr can process. So for example, we are able to query endpoints directly or query Active Directory and other identity stores. You might have an existing asset management system, firewall logs, vulnerability assessment, network management systems or NAC servers. They all have unique information and we can consume that. But typically, initial deployments where you see the most of the value and see or immediate value is going to be in these top three. The passive monitoring with optional flow data and querying network devices so that we can correlate things to where they are on the network. And as you know already, Gigamon hands us that data on a silver platter, whether it's the actual raw traffic or if it's flow data. What type of visibility am I talking about? Well, this is what I'm referring to. It's not a, hey, you've got something that's made by HP based on a MAC address or something of that nature, which is insufficient to provide true understanding of what that device is, because HP and GE and Siemens and many other vendors, they make many different types of devices. So you really need this additional clarity and visibility into the network to be able to provide this level of detail. And I'll show this within the demo and give you real examples, but it's this level of detail. So it's not just, hey, I think you have a Axis device. It's a, oh, you've got this specific device. It's a network camera, this model, serial number, which specific operating system, what firmware. Tell me more about the grouping. So if I want to see all the devices which are under the grouping of physical security devices, I can have this automatic categorization or at the network camera level. What are there any security related incidents and risks related to this device that I will feed this information to my security and incident response tools? Where is it located? Again, this is why it was so critical to have that mapping of device intelligence to network intelligence, because now I can say, here's what this device is, here's where its current or last IP, VLAN or SSID information, interface, first and last seen and location. This is valuable intel that is shareable to all of your other systems. Now, the next piece is that Gigamon will hand us on a silver platter is all the flow information. So we're able to extract all the different communications specific to this security camera or all security cameras of this type and say, this is what they do on the network. And I'll show you in the demo how we, it's a very nice interface. We're being able to quickly see all the different things these devices talk to, which things are normal, which things are not, and provide it in two different ways of looking at that data to your choice. And then use that as the basis to say, this is what your devices do in your environment, not in somebody else's environment. And I've had this conversation with many, is that there is no cookie cutter to saying this is what this particular device does in every environment. It really depends on how it's configured, and it's going to have unique communications based on, say, this camera, where you have video recording and archival servers. It's similar for all these IoT devices. You have a very unique communications, but we're going to figure it out what's unique for your environment and track when there's anomalous behavior. We'll also leverage this genome of communications to be able to translate it into a language that's universally understood by your enforcement points. So often, this is one of the hardest parts of securing IoT devices is, if I was to secure these devices, where do I start? Do I start doing raw packet captures and analyzing the firewall logs or doing raw flow analysis? No, we'll do all of this as automated within our tool to then say, you want to apply an ACL to your switches? You want to do this through your network access control solution like ClearPass and ICE? Do you want us to apply this to your firewall? It could be Cisco, Palo Alto, Checkpoint, Fortinet. So this is what automation is about, and this is what's required in the IoT hyperconverged network. So at this point, I'll jump to a demo so you can see some of these things live. So let's start off, and I'm going to let this show all the devices that we have within the network. And we can see we have over 14,000 devices in this particular network. I'm going to show you that very quickly, that profile view, so I can see the different types of devices that are within my network. And you're seeing it's everything. So we're seeing whether it's building automation, the user devices, the unmanaged systems, things that might be connected, which may or may not be part of your security policy, these little things that are listening to everything you say, building automation, you name it, we are out there being able to track where they're at and exactly what they are and provide the details. So let's just look. I see I have a Clover Networks, looks like a point of sale system. I have 20 of those. Let's see what those devices are. Let me go ahead and jump into one of these and see the type of detail. And we'll see that here's the device, the POS made by this vendor, model. It's running Windows 10. You're seeing detailed OS information. We're seeing the grouping. We see that there's one alarm, but it's it had one medium vulnerability, and where it's specifically located in my network. You see there's some known vulnerabilities. So we will auto-correlate these devices to existing vulnerability feeds and threat feeds. If this was a medical device, you might see some FDA recalls. Network stats. What is this device? Where has it been in its life across the network? So we will track if this device moves, what its IP address is. We'll see flow information. What is this device doing? And I'm going to, each one of these little steps in the staircase is a different thing that this device has talked to. So you can see it was talking to this IP, some port protocol application, how many times first and last, how much traffic was shared, and be able to really look and say, oh, I see this thing talks outside. What are the external communications? And I see there's 3 here. Now, here's a classic example. I see there's communications. This is, for those who know, it's Google DNS. And I could say, you know what? That might be safe or normal traffic, but you know what? In my network, I don't want that to be allowed. My devices should be getting DNS from my trusted DNS server that's internal. And so what we'll be able to do is be able to say, you know what? Let's go ahead when we show you what's normal or not, I can add and remove things to the baseline and say, I am not going to allow certain conversations. I don't want that to be deemed normal within my particular network. So that's just one example. And just looking at this particular type of device, let's go where I would normally go if I'm going to start searching for things. I like going to our inventory dashboard because it quickly shows me all the number of IoT devices, non-IoT, things like, this would be things like user mobile devices, workstations, servers, networking devices. And you can see how many things have been discovered in the last day, week, 2 weeks, how many have PHI data if I'm healthcare, how many have been offline, have things been walking away, see things that haven't been on the network. Is it something that should have been on the network but was no longer? You'll see by classification, and certainly this is an area of great interest, which is being able to see how many types of devices you have. All of these are linked, so I can then quickly jump how many devices are in each VLAN, subnet, and we're going to see other information, ways of filtering it. I'm going to just really quickly drill down into, I want to see my facility device, because all organizations will have facility devices. And I can see this by classification. I can look at the pictures. And this is a interesting one here. I'm just going to look, but again, just to show you that we're going to get this detail. And this was an interesting one for me because my start of my career many years ago, it was working with Tandy computers. And for those trivia, the OS 9 was what the Color Computer 3 ran. So it's telling you how long in the tooth some of these systems will run these operating systems. So that's just a quick example of being able to get that level of detail. And go back to my dashboard and see other ways of filtering this information. So I see here I have things I can see based on their operating system, manufacturer, which ones have communications that are seen, which ones are running management applications like, oh, I still have things running Telnet. My boss told me I shouldn't, this is not supposed to be on the network. Quickly find which those devices are. I can then block that traffic or have them, have those services turned off. So you see a wealth of information, even down to like the location and the types of devices and whether, how they connect to the network. Well, I like this Windows 7 because this was recently announced as end of support. So I see I have many different devices that fall into this group. I'm going to look at a medical device. Again, very rich detail. Here we said it's Windows 7 based. We're even seeing some DICOM PHI data for this particular device. Again, this is the type of information that we'll share with many different systems. I see that there's some known vulnerabilities. Because we're getting rich, detailed information through the Gigamon Visibility Analytics Fabric, I'll be able to even see down to utilization for this healthcare device. This is critical for our healthcare customers that want to know how are things being used down to what type of case studies and operations. So I can then map this. We have a whole module dedicated to utilization. So I can see within a calendar and by day and by hour, how efficiently these very expensive resources are being used. And then I'm going to go ahead and look at the flow genome, and you're going to see things that you should expect to see, like DICOM traffic. So here I'm seeing on this device, it has very specific communications with different DICOM peers, but because we're able to decode, that's why we're able to see rich information like this, is because we understand these applications, information you would never get through other means. So let me go real quickly. I want to show you a couple other type of things. I won't be able to show you everything, but that we do have the security dashboard. So I can see different types of risks and vulnerabilities. So these are the things that would be inherent to the device. Which ones have password vulnerabilities? Which ones might be running impacted through Urgent 11? Which ones have known vulnerabilities versus those which are confirmed software vulnerabilities? Things that are based on the communications internal to my network or external. Are they going to bad sites? Is data being exfiltrated? And then being able to quickly see at the levels of risk to jump and see which devices are at these different risk levels. Let's just quickly look at software vulnerabilities. And you'll see that I've consumed information from other vulnerability assessment systems. So we will not only consume this information and be able to correlate that into the risk of this device with my enterprise vol management system, but I'll also be able to feed our intel to tell Tenable, for example, these are the devices that we know are very sensitive to scanning. So we can update and say, this is the group of those devices, and keep that membership current, even if they move around the network or they change their IP. So now you do not have to worry about knocking those and disrupting your service. So that's an example of how the security information is being used. I'm going to show you one more example here, which is I had previously, I want to look at facility devices, and actually we already did that one. So I want to quickly look at the physical security devices. And I want to look at this let's look at this in a table view. And all of these things can be downloaded to reports, and you can create any data you see can be made as a custom view or custom report. And so in this case, I really want to look at the devices. I just added a bunch of new cameras, these P5624s to my network, and I want to see how they're doing. I see I've got one red alert for this one. And in this case, if I look at the security incident, I see that there's a password vulnerability. And this is common for a lot of cameras. They get shipped with default passwords or no password, or maybe they were configured with something that was easy to guess. And we'll be able to detect those devices, like your cameras, which are running that have a default or weak password. Let me look at this other one, the same type of camera, but it's got a different error, security incident. And here I see this thing. Well, there's something very concerning here, and I see that there's some Trojan activity. I can look at the details in terms of what I should do about this device. If there's a CVE associated, we'll link that to the vendor site or the database feed. Here I'm seeing the actual trigger packet, which I can then copy and analyze if I so chose. But here's another one which is very interesting, which is a behavioral violation. It means this device has been behaving in a way that was unexpected. And by the way, it happened 7 times. Well, what does that mean? Well, let's go to our flow genome again. And this time, rather than nice, cool colors like blue or green, I'm seeing some yellows and oranges. And what you're seeing here is there's those 7 communications which were unexpected, and they're going outside my network. And this is of high concern. And I can see that I'm going to places that it should not. So let's go ahead, and now I can segment this one device. I could even do a quick rapid quarantine directly or through my NAC system or firewall. But let's go ahead, and I'm going to take and create a policy for this entire group. So I just put these devices on my network, and I realize I only want to allow the things which are safe. So I'll filter out the bad stuff for a moment. I only, other way around, I only want to allow the good stuff. So I'm going to go ahead and create a policy, and you're going to see when I look at this, the only things which show up are the blue and the green. The yellows and oranges are not going to show up because those are the things I want to block. Let's go ahead and segment this traffic and protect my network so none of these cameras can be impacted. Now, when I generate the CLI, you're going to see the representation. This is what the firewall rule set would be for all different vendors or switches, wireless controllers, or your network access control systems. We're providing this in the native speak of those systems, and I can copy and paste that to hand off to those relevant admins, or click a button to say, go ahead, lock down these devices so none of these security cameras can talk outside my network on ports, protocols, or peers that they shouldn't be. Very effective way to create true microsegmentation, which is based on the real traffic in your network. And I'm going to give one last example here, which is once I've started instantiating my controls, I want to see how things look at a big scale. I want to see the big picture. And this is actually, once we use deploy, we'll see customers that this is one of the first screens because they can see all of the different types of devices, physical security, printers and copiers, retail devices, even automobiles. You park too close to the building and you jump on the company's Wi-Fi, we'll see you. Facility devices. And in healthcare, you're seeing many different types of medical devices. So any one of these, and the things on the inner ring are things that typically reside or shared services within your data center, and those things which exist outside. And we'll classify those as well based on whether they're domestic, international, whether they're rated to have good or bad ratings, or if they're a public service. Now I'm going to look here real quickly at my physical security devices, and I see all the different types of devices and how many are part of this group. I can also look and say, what VLAN? So if you have a security, a lot of customers will put their security cameras in an out-of-band or a dedicated VLAN. I can say, well, wait a second. I've got 2 devices that are in unknown. I could click on those very quickly and assign them and automatically put them into the right VLAN. Or which ones are they in by subnet? So if I have some customers that would have a very specific IP addressing scheme, and you know which specific subnet they were in. So we'll quickly ferret that out. Now in this case, I want to see, I've got some conversations. I already know I had a camera that was talking outside places it shouldn't have. And here I can quickly see that I have access cameras and some of my other cameras in my network, which are talking outside to these different domains. And let me go look at the world view so I can see which country they're actually going to. And here you very quickly see, and this is where we ferret out and say, yes, that medical workstation was actually connecting to a Bitcoin site. This camera was going to a country that it shouldn't have been doing. This, whatever that device is, you quickly see these communications which should have been locked down. And now we've given you the tools to automate their control in the system. So hopefully you kind of got a gist of how we're providing complete visibility into the devices and that are on your network, especially those hard to find and discover and detect IoT devices, and providing very rich classification, what they're doing, are they vulnerable, are they at risk, are there any inborn threats, and then creating a way to understand how to actually segment them on the network in a very efficient and automated way. But that was all made possible by the data we collected. And that just brings us back to that original premise, which is if you have a fantastic data collection system like Gigamon's Visibility Analytics Fabric, you now get this total visibility across your entire network. So with that, I'm going to leave it for some final questions.
Awesome. Thanks, Craig, and thanks, Gordon. So the first question we have is, how does Ordr work with existing NAC solutions?
Great question. So we have deep roots actually in network access control, both engineering and product management. And so we will automatically feed all of this rich data to those network access control solutions so that they now become infinitesimally more intelligent. They now have the clarity that they lacked before. There are some basic restrictions in most NAC solutions in terms of their ability to see things. So we will fill in all the gaps and give you absolute clarity, and things like, are these devices at risk with operating systems? So all the policies can be generated based on that information, but we'll take it another step further. So if you want to quarantine a device that you know is acting rogue, we will automatically work with the NAC system to automate the quarantine. We will automatically build and generate the segmentation policies using its native methods, whether it be things like DACLs or downloadable user roles, group-based policy like SGTs. So we work extremely well and will accelerate essentially any NAC deployment with better outcomes.
Awesome. And then Gordon, I have one for you. Are there any protocols that Gigamon Fabric can't handle?
Yeah, that's a fair question. Actually, there is, as long as it's a protocol that gets transported by Ethernet, there actually really is no limitation. Obviously, the most common protocols that people want to handle are anything that's IP carried, and TCP transported. However, we basically handle any type of protocol that gets transported across, uses Ethernet as the basic medium, and we can also then filter and even detect certain types of traffic that's not even IP related. But when it comes to IP protocols themselves, applications, even the application layer, any applications not very common or is very unusual, we can even detect those and weed those ones out to either forward out to a tool such as Ordr, or possibly even ignore if it's something that's completely irrelevant.
Perfect. And then I think we have one more question. Craig, this one's for you. Do you require sensors at every location?
The short answer is no. So where we normally position ourselves at more central locations where we can, where a lot of the traffic traverses, and the ability to augment that with things like network query and NetFlow. But to get the richest set of information, especially about localized traffic, that's where, while one option is to deploy a local sensor, this is where the marriage between Gigamon and Ordr really shines, because Gigamon will already have that very detailed and rich ability to collect that data, whether it's raw traffic or the flow or metadata, and be able to seamlessly feed that into a more centralized sensor, so that we can provide you complete visibility across the enterprise with a minimal footprint.
Great. Well, we're almost at the top of the hour, so thank you, Craig and Gordon. That was a great presentation. I'm sure a lot of the audience members took great takeaways from it. So thank you everyone for joining us, and we will send a recording after this webinar is over, and hope you guys all stay safe and stay well, and we'll see you next time. Thanks.
Yeah, thank you.
Thank you.